you can sub in as 3 and 4, can't you? So that is H and that is K for the vertex. So we could, part A, just make sure you say that H is 3 and K is 4 instead of, I think one or two of you put it into the function and I had to find it. Maybe you, Derek, was it?
No, I just said it.
Yeah, so we can put it into the function as well, and it should look something like that. Okay, but this is the answer. Okay, so part B then uses this and says, right, find the value of A, but we got this other point, Q1 minus 4. Perhaps at some stage, this is a non-calculator, but you could just draw a little sketch and see, right, I've got 2 points on this graph. Maybe I'll have an idea if it's a negative or a positive graph. I just plot those 2 points. 3, 4 is here, little sketch, 3, 4, somewhere there. And this point, 1, negative 4. So 1, negative 4 is like down here maybe. So what shape graph is it?
Sideways.
You think it's gonna go like that? Well, it could be. Could it be like this?
Maybe.
No. Because what is this? This is a vertex.
Yeah.
So that's the highest point, so, or the lowest point. So it has to be this one. So it's a sad face. So that's a little, you could do a little check. You didn't have to do that. Do a little check. Your A should be negative. Let's find A, knowing that this point is on this curve for X and Y. So negative 4 is equal to A. We got 1 minus 3 squared plus 1. I think 1 or 2 you forgot to square this. So that's A is, what's that, negative 2 squared plus 4. So subtract 4, we get negative 8 is equal to, this squared is positive 4, so we get A is equal to negative 2.
Yeah, that's square.
Yeah, that will happen. All right, let's look at question 2. Let's have that in the, oops, don't do that. Okay. Don't have that in the background either. Don't have that in the background either. Don't want that in the background either. Don't want that in the background either. Don't want that in the background either. Jeez, let's get a blank page. I could move the book, but I like leaning on the book. All right. All right, so we got this. This is a rational function, no squareds here, so it's just a normal rational function. It'll look something probably like this. Asymptotes are at x negative 5 and y is equal to negative 2. This one I could also sketch pretty easily. Like up here, x is negative 5. Okay, there's an asymptote here and there's an asymptote. No, x is negative 5. Oh, that's made a mess of that. X is negative 5 is an asymptote, so here, and y is 2 is an asymptote, so here. There's 2 asymptotes. Okay, maybe we'll need that, maybe we won't, but we know there's asymptotes. And we know the point 1 and negative 112. So 1 and negative 112. So there's a point like here maybe. All right, so we already know the shape. It's going something like that and something like that. So it wasn't the one I drew. Scratch that. Okay. We want to find what? A, B, and C. Probably the easiest one to find first is C maybe. Because we know for an x asymptote that this would equal 0. So now 2x plus c has to equal 0. So what value, and we know that the value for x that makes that 0 is negative 5 because it gives us here. So we know that 2 times negative 5 plus c must give 0. It must be asymptote. So c then is going to be, I think that's negative 10, then c, add 10 both sides, c would be 10 from that. That's the answer makes sense. So we have a bit of it. So our function, which I'll start to write down here, maybe we know it's ax plus b, and we've got 2x plus 10 now at the bottom. So we found what c is. Now we must find a and b. We should know that the asymptote, the y asymptote would be these two, isn't it? Yeah. A over 2 is the y asymptote in this style of function, and that is 2. So the y asymptote is 2. So we have this. So a must be 4. So a must be 4. So this is a 4 now. And now we just have to find b, don't we? So we do have this point. We haven't used it yet. Let's use it now. We have this function. We know that if we sub in 1, we get negative 12 out. So let's sub in 1 and get negative 1 12th out. So if I sub in 1 for x, 4 times 1 plus b, 2 times 1 plus 10. Luckily enough, the denominator here is 12, isn't it? 2, yeah, so it's just really the numerator we care about. Minus 1 is equal to 4 plus b. Of course, if you're in the IB exam, don't write outside the box, but I'm doing it here just to space things out better. And b is going to be negative 5 from this. Okay. Not many people got that fully right, I don't think. Which is a surprise, it wasn't too challenging. Okay, this one was answered quite well, so I'll go through it fast. The third term of an arithmetic sequence is equal to 7. So I would set up something like this. First, second, third term is 7. We know that this is U1 then, something like that. The sum of the first 8 terms is 20. Okay, so we know if we have all 8 terms, I've run out, 4, 5, 6, 7, 8. All these 8 terms add up to, so U8, 20. Find the common difference on the first term. All right. And so we can do a number of things here. We can use our formulas if you like. The sum of 8 terms formula is probably where I go to first. Is n over 2, isn't it? So that's 8 over 2. And we have these two, so it'll be U1 plus U8. Use the shortened one if you have it's the second one of the two. I don't have U1 or U8, but I do know the sum of 8, the first 8 terms is 20. So I have 20 and 8 over 2 is 4. Now, how do I get U1 or U8? Maybe in terms of differences, I can get them both. Wouldn't this one be U1 is 7, take away 2 differences? So minus 1 difference, minus 2 difference. So this is 7, take away 2 differences is U1. And U8 then is 7 plus 1, 2, 3, 4, 5 differences. 7 plus 5 differences. What I've set up now is there used to be 2 variables here. Now there's only 1 variable, our difference, and I can solve this to get the common difference. Most of you guys got this anyway, so I'll fly through it. So 7 minus 2d plus 7 plus 5d, removing the brackets. So the 7s will cancel. This is 3 differences, so 20 is equal to 4 times 3 differences. It was 20 is equal to, have I done that right? No, the 7s don't cancel. What am I doing? 14. They're the same size. Plus 3 differences. Okay, so it's not going to be as easy as I thought. So 4 times 14 is 56. 4 times 3d is 12d. And the difference is going to be negative 36, 12d. So d is negative 3. And then we can sub it in to get what the first term would be, because we know it's 7 take away 2 differences. So the first term is 13, yes. Very good. I think you all got that, did you? All that's here, yeah. All right. Okay, proof by induction. All right, so tapas, let's test first. Base case. N is all positive integers, so the base case is n equal to 1. So I test that, so 1 squared plus nothing, because that's what n squared would be. Is that equal to 1 plus 1 plus 1 plus 2 times 1 plus 1 all over 6. So let's work this out. 1, so this is the left-hand side is 1. The right-hand side is 1 plus 2 times 3, I think, which is 6 over 6. So 1 is equal to 1. Left-hand side equals right-hand side. So base case holds. Or it's true, or something like that. So that's T. A is assume. So we're going to assume true for n is equal to k, which is just a rewrite of the first thing. 1 squared, 2 squared plus ... k squared is equal to k plus 1, 2k plus 1 divided by 6. Okay. P for prove. We're going to try and prove it true for n is equal to k plus 1. 1. N is equal to k plus 1. Very good. So we're going to replace k plus 1 now. So we get 1 squared plus 2 squared plus k squared plus k plus 1 squared is equal to all of this, k plus 1, yeah? K plus 1, so this k, this would be k plus 2, wouldn't it? And this would be 2k plus 3 when I put in k plus 1. 2k plus 3. Once again, don't write outside the box. This is terrible example by me. Right. What do I do next? Panic? No, definitely not. We use the assumptive step. We go, right. This has to go in here somewhere on the left-hand side. So this can replace all of this if we see it on the left-hand side. And we can see it clearly here. All of that is there, so I can replace it with this. So from assumptive step, we can say k times k plus 1 times 2k plus 1 all over 6. This can replace all of this. So that's gone now. And I still have my plus k plus 1 squared is equal to all this still on the right side. Now we're going to just work on the left-hand side here. It is the recommended way to do it. So I'm proving that this equals this, and it doesn't equal this yet, so we can't presume that it does. So I'm just going to try and prove that the left-hand side equals the right-hand side. And the only thing I can do is find a common denominator here, combine these two, and hope for the best. So common denominator is 6. So if I write it all over 6, I get this. This has to be multiplied by 6, I think. And it's now all over 6. All right. Right. Now at this stage, I stop and go, right, I want this to look like that. So this has been factorized, so k plus 1 is a factor of everything. That's what I see. I see, right, I'm going to get this k plus 1 out the front first. So is k plus 1 a factor of both these? Yes, it is. So I'm going to pull that k plus 1 out the front. And what am I left behind with? I'm going to factorize these two terms. Left behind here is k and 2k plus 1. See that? So I've taken out this k plus 1. And left behind here is plus 6k plus 1. All right, and that's still all over 6. Okay. Next step. My next thing to do is, right, these two multiply to form a quadratic, I think. So at the moment, I can't see a way of factoring out k plus 2 or 2k plus 3 out of either of these. So I'm just going to combine them. Hopefully it's a quadratic that factorizes to be the same as that. So I'm going to multiply it out. K plus 1 sits outside here. I'm going to get 2k squared plus k plus 6k plus 6 all over 6. This is why I have the notebook underneath. Combine these, this is 7k in the middle, so I get k plus 1 plus 2k squared plus 7k plus 6. And you can kind of like use it almost like a cheat here. Is this the same? When it multiplies out, yes it is. So I kind of know it factorizes already to give that. But you can factorize, we'll factorize it. Let's put it in the same order, k and 2k. K and 2k multiply to give k squared. I want to make 6. Let's make it with 3 and 2. I'm just following what's up here. Let's make it with 3 and 2. That makes 6, and let's make both things positive. Does that make a 7k in the middle? Yes, it does. 4k, 3k, 7k. I've done it. Congratulations, me. And then you can say some version of base case holds, or for n is equal to 1 or some of that, and n is equal to k holds, and n is equal to k plus 1 also holds. So therefore, by mathematical induction, it holds for all n element of z positive. Okay, moving along. The first 3 terms of an infinite geometric sequence are those, right, find the expression for the common ratio. All right, so the common ratio expression is pretty straightforward. For a geometric sequence, it's 1 divided by the other. It's now u2 divided by u1. So the ratio is going to be the second term divided by the first term here. So 4 over k minus 4. Or you can say k plus 2 divided by 4. u2 divided by u1 or u3 divided by u2. Hence show that k satisfies this equation. Okay, well, both these equal or, so you can say they equal each other. This is how we do it. They equal each other. The two ratios must be equal. So we set them equal to each other and then we cross multiply or something like that. Common denominator thing. And multiplying out, I get 4k is equal to k squared plus minus 2k minus 8. That's not a k, that's a 4. What am I doing? It's 16, sorry. 16. And then bring over the 16, k squared minus 2k minus 24. I don't know why I wrote k here. That was a 4. Okay. And that's it, proven the first bit, so it satisfies. Part B then, find possible values for k. So that's, all right, factorize this. Where does it equal 0? We get k and k, 6 and 4 probably, minus 6 plus 4. So k is equal to negative 4 or k is equal to 6. Two of the answers. Which you could have done without actually doing part. So if you give this, you can go on anyway, even if you can't prove it. And then find possible values of the ratio from this. I just sub in this, don't I, for my original thing. So or is equal to 4 over k minus 4. This is going to give us two answers. The ratio is either going to be, if minus 4 is here, I think the ratio is going to be negative a half, which is okay. And if k is 6, I get 4 over 6 minus 2, which is 2, which is the ratio is 2, if I sub in 6. Okay. Question 6, which I haven't done yet. So hopefully I can figure it out now. The arts and crafts stores 6 different types of charms. Customers can personalize between 1 and 3. Determine how many is if orders not. Yeah, so the first one is definitely permutations, isn't it? And if order is not important, that's combinations. Okay. So combinations, permutations, order is important, that's a permutation. So there probably is more permutations than combinations. Okay, 6 keychains, between 1 and 3 charms. So there's 3. Let's find out whichever. Oh my goodness. Stores 6 distinct types of charms. So the customer can either do 6 pick 1, 6 picks 2, 6 pick 3, yeah? 6 pick 1, 6 pick 1, 6 pick 2, and 6 pick 3. Okay. So that using our formula, so you can get to the formula booklet, which I don't have beside me. So we go formula booklet. If we're not sure how to do this without the formula, formula is our friend, of course. Here we go. No, permutations here. Okay. So to get permutations, you go to the page 3. N factorial over n minus or factorial. If you're stuck in the exam, that'll give us our permutation. So we got 6 and 1 here. So that's 6 and 6 factorial all over 6 minus 1 factorial is 5 factorial, isn't it? And then I think the next one is going to be plus 6 factorial over 4 factorial plus 6 factorial over 3 factorial. Now we didn't have a calculator for this question, did we? So 6 factorial divided by 5 factorial is, you can do it the long way, 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. Cancel, cancel, it's 6. Do the same for the next one, and the 4s will cancel. So this is 6 times 5, isn't it? That's 30. And do the same for the next one, and the 3 down to 3 will cancel. So we got 6 times 5 times 4. So this times 4, which is 120. Add all those up, we get 36. 156 maybe?
Yeah.
156. Okay. Right. And I think if the selection is not important, it's just the same thing, but 6 choose 1, 6 choose 1, 6 choose 2, 6 choose 3, yeah?
Yeah.
All right, so that's not too bad. I thought it was a little bit harder than that. Okay, so 6 choose 1, 6 choose 2, 3. You got to use the formula again, don't we? So the this formula is n factorial. I'll write it down here. N factorial over or factorial. N minus or factorial, of course. So 6 factorial in this case, all over 1 factorial times 5 factorial. I think. Yeah. And this is 6 factorial all over 2 factorial times 4 factorial. And this is 6 factorial. I'm just using this formula a little bit quicker now. 3 factorial over 3 factorial. Oh, I have to do this without a calculator. Great fun. This one's going to give 6 again, I think. Plus, this one's going to give 30 divided by 2, isn't it? So 15. You can use the answers above. 6 factorial, 3 factorial. So divide then by 3 factorial, which is 6. Divide this number by 6. It gives 20. Add these up. We get 41, I think. 41. Okay. All right. Under pressure in an exam, maybe not that easy, that one. But I think it was pretty straightforward after reading it for... All right, this one was not straightforward. I'm not sure. Maybe 1 or 2 people got it all correct.
How many did you get? You got all
I
correct.
don't know.
Yeah, it was...
This one is pretty fun because you have to make it a
Pretty
sound.
fun.
Yeah, so you're thinking how many ways to make x squared and how many ways to make x from this. So I would have done this first out. I would have looked at both of them separately. I think you can do this one out pretty quickly, I think, the full expansion. So 1 plus x and 3, 1, 3, 3, 1, 3x squared plus x cubed, yes. And then the other one you can do out as well. 1 plus px4 also starts with a 1. And then, what is it? Plus, it's 1, 4, 6, 4, 1 from the Pascal's triangle anyway. And this is px to the power 1, px to the power 2, px to the power of 3, and this is px to the power of 4. And they're all going to be positive because they're all positives. That's it expanded. Does that make sense? Okay. Now I know that this whole thing has got to be multiplied by this whole thing. They are multiplied together to form this. So I need to figure out what multiplications are the ones I care about. Let's start with what multiplications make an x, because I know 1 times 1 makes the 1, so that's okay. But which ones make the qx? So yeah, so qx is formed by 1 times this plus 1 times this. Correct?
Yeah.
Okay, and that's the only way of making an x. The x's don't really matter anymore. So I just have q is equal to 4p plus 3. That's one equation. Can't solve it yet because we have 2 variables there. So let's go find the other one, which is how I find x squared. Let's do it over here. 93, why did I write it like that? 93x squared is equal to, right, how do I get x squares out of this? Well, one way of doing it is 1 times this, 6p squared x squared. That's one way. 1 times 3x squared is another way. There are more ways though, yeah? 3x and 4px multiplied would give one as well. So that'd be plus 12px squared. Any other way of getting it? No, I think Yep, so there's 3 ways of getting that, which I think most of us missed. The x squareds don't really matter anymore, so we get 93 is equal to 6p squared plus 3 plus 12p, which I think I could tidy up a little bit. Subtract, I get 90 is equal to 6p squared plus 12p. Okay, that's the second equation. So I have 2 equations, two unknowns, but this one can just be solved because there's no q's in it. So I'll just probably solve this one before I go back to this other one. Solve, get me 2 answers for p. Now it does say possible values for p and q, so I imagine there's going to be 2 values, and there should be 2 values. Here, yeah, dividing everything by, does 6 fit into 90? I think so. Yeah, so if I divide everything by 6, it's a much easier equation. Bring everything to one side. I think I get p squared plus 2p minus 15. If I bring everything to one side, and that equals 0. Factor out this, I get 5 and 3 plus 5 minus 3 will make this plus 2p. So that means p is equal to positive 3, or p is equal to negative 5. And to find q, I need to put both of them in here. So if I put p in as 3, I get 4 times 3, which is 12, plus 3, which is 15. If I put p in as negative 5, I get what? Negative 17. That's negative 20 plus 3, so q is negative 17. Okay? So that was definitely I think just finding these 3 was the key, wasn't it? All right, let's move on. I think the last question. Our old friend, logs. If I solve these simultaneous, okay. So I don't really like the look of this with the logs in it, so I'm going to try and get the logs out of it. 1 can definitely be rewritten. So I'm looking at this first equation here. I'm going to rewrite it in terms of log 5. So that's going to be log 5 plus, I'm going to put the 2 into the power using the rules. I get log 5, 7y. So I want to write this without logs. I think I can do it if I combine these 2 together. I think I can remove the logs. 5, so that's multiply, isn't it? Log 5, 5x squared is equal to log 5, 7y. Now I can remove the logs because I know that 5x squared equals 7y. Only now can I remove. It's got to be just 1 log on each side to remove. Okay, that is one of the equations done. Similar to the last thing, I'm going to end up probably with a simultaneous equation. If I follow the same route for this one, 6x minus 1 is equal to, I'm going to do log 7, 7 plus log 7y. Combine these 2 and then I can say it equals, so that's 7y, isn't it? So I can say 6x minus 1 is equal to just 7y. I just combined using the same thing as the other one. Now I notice I have 7y on both, don't I? Which means that 5x squared is equivalent to 6x minus 1. So 5x squared is equal to 6x minus 1. Bring everything to one side. That now equals 0. I can get some solutions here. 5x and x. 1 and 1 is going to work out for me. I think they both need to be negative, don't they? To make a plus 1 here. And then x is going to be positive 1/5 and x is going to be 1 from these 2. And once I know what x is, I can find what y is. I can use either one of these 2, which is going to be easier one. They're both going to be not that nice. I'll use this one. So 5x squared. So 5, I'm looking for the y value here. Maybe I'll just do it up here. So if x is 1/5, I'm going to get 5 over 1/5 squared, which is 5 over 25, which is actually 1/5. So I get 1/5 is equal to 7y. So divide down by 7, I get 1 over 35. And then sub in 1 up here, I get 5 times 1. Oh, that's not too bad. 5 is equal to 7y, so y is equal to 5 over 7. And that's it. Yeah, you could have done that.